Okay, guys, yesterday we were at 5.5 day 1. We were working on example 3, handling the ambiguous case. Keep in mind we were almost done. We just had to find side C. Now the find side C, we're going to take C over sine of C, and that's a small c, the length of the side is what we're looking for. The sine of C, we just found C, which is right here, and we're going to put that in right there. And we were given A at the beginning of all this, and our A is up here at 6, and our capital A is 30 degrees. So now we're just going to pop that stuff in, and now we have A sine of C, because we're going to multiply both sides by sine of C. Pop in our numbers, pop that into a calculator, and we have C in our other version of the triangle could be 1.189. So that closes out that example, but now here's the digging, the biggie, the big kahuna to start today. Flip the page and do the U-try for side-side angle. Solve the triangle ABC. You ready? Go. Turn it off, give it a try, do it on your own, see what you can make happen. Okay, welcome back. I'm hoping that this went well for you, but let's do a couple things. First, let's sketch a picture. So I've got this picture going down, really high-tech sketch here. This is 43.1 degrees. This is my A. Now remember, A across is 186.2, and I've got a B of 248.6. Now my biggest concern I've got going here is about this height. I want to make sure that that height is actually going to be less than 186.2 for it to even be a triangle, because boy, I could just do a lot of calculations, just waste my time. So let's check this out. As a sine of 43.1, and if I'm going to find h over 248, my hypotenuse of that mythical right triangle. So I have 248.6 sine of 43.1 is equal to h. Well, if I can grab a calculator, and I got to go all the way back to my desk to grab a calculator, you'd think somebody would have remembered to do that. Check my mode, make sure it's in degree, and it is, thank goodness. And now we're going to go 248.6 times sine of 43.1, and that is going to give me 169, that's h what we're looking for, so I got 169.861. Well, that's my height. Okay, that's my height right there. So what that's telling me is that there's another side of this. This is another 186.2. So I'm going to be looking at two versions of this. Okay, so keep in mind that that's the case. And over here, I'm going to prep myself for the second version. Maybe I can make a better setup for it or whatever. But that's the first one sitting there. The second one sitting there. Maybe I can make that picture better. Let's make it a little better. And praying, look, smoke and mirrors. I have a beautiful, well, okay, a much better picture. But remember, two versions of this problem. Because this goes to the bottom, this is 186, so is this. But for this first one, I'm going to ignore the red 186 because I'm just going on this triangle. So the first thing I'm going to do is solve for B. Why not? Find B. So I've got sine of B over B equals sine of A over A. And so the measure of angle B is going to be the inverse value of, what is that? B is 248.6 sine of 43.1 over 186.2. Okay, so my measure of angle B is 65.819 degrees. Okay, that's the first thing. So I found B. Now I've got A and B, I can find C quite quickly. So if I can find C, measure of angle C is going to equal to 180 minus 65.819 plus 43.1. Okay, and those are going to combine to help me get a 71.081 degrees for the measure of angle C. And then, after I do that, I will find side C. Remember, the reciprocal of the law of sines. And I like A and sine A, those are good numbers. Okay, and let's keep moving down here because I keep running out of space. Extend that out. So my C here is equal to a sine of C all over sine of A, and we just found C, so we're going to talk about A being 186.2, and we got the sine of 71.081 all over the sine of 43.1, and that'll give me a C side of 257.513. Well, that's from triangle 1. Okay, that's my triangle 1, and I showed you how everything's going to go. Okay, as we get going here. Now this is triangle 2, and remember, the big thing about triangle 2 is really talking about this B, because I've got to find this angle, and I use the idea that this angle and this angle are congruent because of isosceles triangle bases and their base angles. So keep that in mind. I'm really finding the measure of angle A, B, C, and let's say that's 2, so we denote the difference between the two. It's going to be 180 minus 65.819, because remember, this is 65.819 degrees, and so is that. So I get that done. I know the measure of angle A, for lack of a better reason, B2, 114.181, and that's my first thing I found. A different color to find the measure of angle C2. Okay, because this C2 is this angle right here we're talking about, that smaller angle. Okay, so now keep in mind the measure of angle C2 is going to be 180 minus the combine of 43.1 plus 114.181. Yep, and then the measure of angle C2 is 22.719 degrees. Okay, so we got that, finding the measure of angle C. Maybe I should box that in. And now we got side C. That smaller side, let's get a red value there. That's the side I've got to find right up there. Let's get the whole picture so you can see. I'm going to find that red value right there as we go through. So this next one is, again, the reciprocal, and as we go through, we're going to find side C. That's the second C, C2, sub 2, sine of C sub 2 is equal to A over sine of A. Well, the C sub 2 is equal to 186.2 times sine of 22.719 all over sine of 43.1. Well, I get that bad boy in my calculator, and I get it all punched out, and Mr. Foss, if you would, just double check me, would you? Okay, C2 sub 2 is 105.247. Now remember, this is not an angle, but it's a measure, and with the angles, I've got them denoted with degree measures. Okay, I didn't get them all denoted with degree measures as we went through, but make sure you're careful getting those things done, and maybe perhaps we get this and box that in to finish out our problem so it's easier for that grader fella, Mr. Bloom, to find his values he's looking for so he can give you maximum points on your quiz or test coming near you. Now I'm just going to slowly kind of peruse the whole problem here as we go through. Just make sure that things are clear and the numbers are there. Now today is all about applications. And we have 4 applications, example 4, 5, 6, and 7, that we're going to do today with these. A Forest Ranger, Chris Johnson, at Ranger Station 4A sights a fire in the direction of 32 degrees east of north. Ranger Rick Thorpe at Ranger Station B, 10 miles due east of A, sights the same fire on a line 48 degrees west of north. Find the distance from each ranger station to the fire. Well, this is our picture. This is 32 degrees, this is 48 degrees, so we've got some information that we can use to find significant pieces of detail to help us with our problem. This is 58 degrees now, and this is 42 degrees. I have angle C, and angle C should be 80 degrees. Let's double check that. 58 plus 42 is 100, so angle C is 80 degrees. Okay, and keep in mind the measure of angle C was found as 180 minus the combined effort of 58 plus 42, and that's where my 80 degrees came from. Okay, that's the measure of angle C. Now, if I'm going to find this, you got to be careful. They're asking to find the distance from each ranger station to the fire. Well, from ranger station A, I have line B to the fire. And from ranger station B, I have line A to the fire, so don't screw these up. Okay, you got to be careful as we're going through, and because of that, I'm going to be careful by just taking care and doing those things with red for that one. I'm going to do blue with that one. So, and that's going to be purple just for fun. Let's do that. That's going to be a different color right there, purple. Okay, all right, so now we got this going on. We're going to find the length of B. So because I'm length of B, I am now working with, and this will be purple. Let's make that purple so we have that color-coded rail. Okay, so I'm going to go with the length of B, or better yet, station A to fire. Okay, so that's station A to fire. Well, to do this, I'm going to start with B over sine of 42 is equal to 10 over sine of 80. Okay, well, this is going to be equal to B 10 sine of 42 and over sine of 80, and I pop that in my calculator, and I get 6.795 miles. So the distance from station A to the fire is 6.795 miles. And I got a word question, so I suppose I should say a word answer. And I'm going to prep myself. Okay, and we're going to do that one in blue. Station B to fire. And I have A sine of 58. Okay, because sine of 58 is opposite A. And hey, you know, I got 10 over sine of 80. Let's do that again. So A is equal to 10 sine of 58 all over sine of 80. And I just pop that in my handy dandy trusty calculator, and this becomes 8.611 miles. So this is 8.611 miles, that distance. And we're going to hit that there and change that color back to blue, and we got that golden. So that's our answer there, and that's our solution as we go through. Please make sure as you go through this, you recognize that we've already had this triangle set up. The biggest and hardest thing was that direction, you know, west of north or east of north, depending on which one we were talking about. So kind of review those and think about those as we go, but we've got that one going, and we're going to go on to 5. Now in 5, the road slopes 10 degrees above the horizontal, and a vertical telephone pole stands beside the road. So keep in mind, this is 10 degrees. Okay, this is 62, this is 62. Okay, vertical angles still work. This is 28 degrees right there as we're working through. But you gotta be careful with that slope, because if this is vertical, this bad boy is 100 degrees, and this is going to be 52, because I've got 28 plus 100 plus something is equal to 180. And that something has got to be 52 degrees. And that's where that's going. Okay, so we've got that first part of our triangle set up because of that 10-degree slant. But now as I'm going on, the angle of elevation of the sun is 62, and that's where I got that other 62. And the pole casts a 14.5 foot shadow. So I've got this is 14.5 feet. Okay, find the height of the pole. So I really already have an angle that I'm going to use. I've got 14.5 and sine of 28 across from each other. Well, the other one is a in the sine of 52. So I'm looking for the height of the pole, and that due to that slope in the road, I got that thing going on for me. So we're all good. So we're 52, 28, we're set. Now, I'm looking for the height of the pole, and I'm going to take a sine of 52 is equal to 14.5 sine of 28. A is equal to 14.5 sine of 52 all over sine of 28. Pop that in my calculator, and I'm popping out 24.338 feet. Okay, so the telephone pole is 24.338 feet tall. And I should say above ground. It's probably longer because it extends into the ground, but that is the length that we have above ground. Now we turn the page, we're going to be looking at some space exploration. A satellite orbiting the Earth passes directly overhead at observation stations in Town A and Town B, 340 miles apart. So I have Town A, I have Town B, and a satellite passes directly overhead, okay, and they are 340 miles apart. Okay, this is B, this is A, this is C, okay. Now, at an instant when the satellite is between the two stations, its angle of elevation is simultaneously observed to be 60 degrees at Town A. So this is 60 degrees at Town A and 75 degrees at Town B. How far is the satellite from Town A and then from Town B? So once again, just like our fire question, the distance from Town A is length lowercase b, and the distance from Town B is length lowercase a. So when we get this going, our first thing is, let's talk about the measure of angle C. And since I was doing this funky thing with the colors, let's see what I can do about that color right there. Let's see if they'll let me do C that way. Okay, so I've got the measure of angle C is equal to 180 minus 60 plus 75. Well, this is ending up being 45 degrees. So this is 45 degrees, and this is 340 across from that. Okay. Now, if I'm going to talk about this distance over here, if this is 60 and this is going to be 75, let's use those for our colors. So if I'm looking at the distance from Town A, okay, which is B, so the distance from town A. I'm be talking about B, sine of B, which is sine of 75, equals C, 340, over sine of 45. So B is equal to 340 sine of 75 over sine of 45. And I pop this in my calculator, making sure it's in degree mode, 464.449 miles. Okay. Now I'm going to quick find the other one, and then we'll put our word answer in with our word question here. So we're going on, and we're going to talk about distance from B. So we got our distance from town B, which is going to be A sine of 60 is equal to 340 sine of 45. So A is equal to 340 sine of 60 all over sine of 45. And pop that in our calculator, 416.413 miles. So now that we've got that all written down, I suppose that's about it. That's as best I can do, distance from town B, and I've got this distance from town A, and we're golden. Okay, just double check to make sure that that's what we had before. Hey, look at that. Okay, so we're off to example 7, and example 7 is a little bit more involved. Let's read that a couple times. We're looking at, to measure the height of a mountain, a surveyor takes two sightings of the peak at a distance of 3,000 feet apart at the same elevation. The first observation results in an angle of elevation of 48 degrees, and the second results in an angle of elevation of 35 degrees. If the transit he used to measure the angles is 5 feet tall, what is the height of the mountain? First of all, the transit is something that's used to measure. That's the device that he's using to measure, or she's using to measure. And generally, it's this. I've got a mountain there, and they're on the same elevation, and this is here, and I've got 48, and I've got this height, and I've got 35 degrees, and I've got that this is 3,000, the distance from here to here, these two distances. Okay, it's 3,000. Or I shouldn't say these two distances, from these 2 points. This is a right angle, and I want to find that height. Now, part of this I can do with doing some things as we go here. Some other stuff may not work so great, but generally what I'm going to be doing, I know this is 132 degrees. Okay, I know that this is 13. And as I go through, I know this is 48, and that's 90 and 48 is 138. And if I take 180 and then subtract 138 from it, I get that that's 42. So up here is 42. But really what I need is to figure out this distance as we're going. And I need x, and I'm going to get that from my first triangle as we get going here. And I've got the sine of 13 opposite the 3,000, and x opposite the 35. That'll give me my value x, and then I'll use the h to find h, that value x that I found. I think that's probably right there the fastest I can do it. I just wanted to make sure you saw how I got 113, 132, and everything going there. I just triangle sum theorem as we went through. So let's get this show on the road. To find x, and I suppose I've got red there, so let's find x with red. X is sine of 35, okay, that's across from it, is equal to 3,000 sine of 13. Okay, so x is equal to 3,000 sine of 35 all over sine of 13. Pop that in my calculator, and I get myself 7649.349. Now, remember, this is feet. Okay, and that's my x value. That is not the elevation yet. Okay, let's gonna go black, and I've got to get a little bit more room here. In this next relationship, here, keep in mind, we now know what x is. And x is across x was across from 35, but now x is across from 90 in this next triangle. Okay, so now you got to keep in mind that x is across from 90. Okay, so that's going to be our sine of 90 there. Okay, as we get going, when we get this going, and we're also going to use x and sine of 48. So when we get this next one set up, I'm looking at the fact I want height, and I've got sine of 48, because that's our opposite the height, and I have 7649.349 sine of 90, and so h is equal to 7649.349 sine of 48 over the sine of 90. Now keep in mind, the sine of 90 is 1. So really all I'm doing in my calculator is taking 7649.349 times the sine of 48, and I'm pretty much done. Okay, so we can get this value popped out. I'm just going to double check this because I really doubt my fat fingeritis. I only did this number once. So 7649.349 times sine of 48. Okay, now if you wanted to, if you really truly wanted to, you could divide by the sine of 90, but we already know that's 1. So when we get this going, I know that we're going to be sitting at 5684.574. But be careful, 5684.574. I gotta add 5 into it because the transept was 5 feet high. I gotta add 5. So I'm gonna add up with 5689.574 feet. So the, what do we want to find? What is the height of the mountain? Height of the mountain is, and that's the way it is. Okay, well, that's our second day assignment there. It's on the front board and it's also up in front of you. You got day 1 and day 2 on this video. I'm hoping that these videos are making sense and helping you along. If there are some confusing things, just let me know about it, and we can chat about the things that went awry. But hopefully this is helping you be more successful than not. Have yourselves a great day and enjoy the weather.